Good morning, North Pontotoc High School physical science students. This will be the last section that I'm doing for chapter 8, which is on solids, liquids, and gases. So if you have watched the previous ones, we will be finishing up on this. All right, so the last section is section 5, which is called uses of fluids. Note number 29, buoyancy is the ability of a fluid, which means a liquid or a gas, to exert an upward force on an object immersed in it. This force is called the buoyant force. The amount of buoyant force determines whether an object will sink or float. The first principle that we're going to talk about is Archimedes' principle. Says the buoyant force on a submerged object in a fluid is equal to the weight of the fluid displaced by the object. If the buoyant force is less than the object's weight, the object will sink. If the buoyant force equals the object's weight, the object floats. So you can study this picture, and it really helps you understand why objects sink or float, especially if you look at the last picture where the ball and the hull, like the hull of a ship, they weigh exactly the same thing, but because of the different shape, which means the volume is different, one will sink and one will float. Archimedes' principle explains why steel ships float. If you form a steel ball into a hollowed out bowl shape, as it sinks into the water, it will displace much more water than the solid bowl did. Soon, it displaces enough water to equal the weight of the steel, and it floats. Pascal's principle is another principle that we want to talk about. It states that the pressure applied to a fluid is transmitted unchanged throughout the fluid. An example of this would be if you squeeze one end of a balloon. Think about how the balloon pops out on the other end. And this is what hydraulic machines use to move really heavy loads, is the concept of Pascal's principle. So if you look at this picture, you can see how it doesn't take a lot of force on the front end to create enough force to actually lift the car up. So this is Pascal's principle. I would really encourage you to find this video and watch it because it's really interesting. And then we're going to talk about Bernoulli's principle. It says that as the velocity of a fluid increases, the pressure exerted by the fluid decreases. The ability of an airplane to rise into the air is an example of Bernoulli's principle. An airplane wing is curved on the top so that as the wing moves forward, the air passing over it must travel farther than the air passing below it. This causes the air pressure above the wing to be less than the pressure below it. The result is a net upward force on the wing, lifting the airplane in flight. You can study this picture. Bernoulli's principle also explains how baseball pitchers can throw a curveball. If the pitcher puts a spin on the ball, air moves faster along the side of the ball that is spinning away from the direction of the throw. The ball's spin results in a net force that pushes the ball toward the low pressure direction. This causes the ball to curve. So if you're interested in baseball, that's pretty cool. Fluids flow faster when forced to flow through narrow spaces. As a result of this speed increase, the pressure of the fluid drops. The Venturi effect is an example of Bernoulli's principle. The Venturi effect occurs in cities where the wind is forced between rows of skyscrapers. If you'll look at this picture, you can see how when it's going in between the two smaller spaces, it's going to go faster, and this is going to cause it to have a lower pressure. The reduced air pressure outside the buildings during strong winds has caused windows to be forced out by the higher pressure inside the buildings. So this phenomenon happens in large cities where you have big skyscrapers. So this finishes up our lesson on chapter 8. So you can go back and you can look at all the sections. Make sure you link these with the notes that were in the packet, and that way you'll be able to follow along. So if you have any questions, you can just send me an email at my school email. But otherwise, I hope you have a great summer